Welcome to Dr. Pat TV. This is part two of the antiderivative. Okay, so in part one, we were talking about inverse functions and about how when we do the antiderivative using the power rule kind of idea, we're doing it in the opposite thing in the opposite order. And so basically, instead of multiplying the old power, we're going to divide the new power. And instead of subtracting one from the power, we're going to add one from the power. So if you've got it down already, here's some examples to do. Go ahead and take a moment, write these down, do the antiderivative, and then check with what I'm going to show in a moment. All right, our first one, the antiderivative. When we do antiderivative, that little symbol there, that integral sign there, nice big elongated S. Basically, that's our little symbol for us math people to say, do the antiderivative. All right, so before you do the antiderivative, just like derivatives, one of the things you want to do is do a little rewrite. So rewrite that square root there, rewrite it into the appropriate power. That's the 1/2 power. So that's what we do. We first do a rewrite. I'm still writing the integral sign because that's still telling me I still have to do the antiderivative. Okay, but once I do the antiderivative, once I add 1 to the power and then divide by that new power, once I do that, you notice that the antiderivative symbol is gone. So I don't need to be told to do it anymore. All right, so that's what I got. Added 1 to the power and then divided by the new power. And then you see this plus c here. That's our constant of integration. That's basically when we're working backwards, you could have had a constant. The original function here could have been plus 17. But when you take the derivative, when you go back the other way, when you take a plus 17, you do its derivative, it goes away, it goes to 0. So right here, this 3x to the 1/2 is the result of the derivative. It's the derivative. And so when you do the derivative, the constant goes away. So if I start with the derivative and I go backwards to find the original, it could have been any number. And so that's why until we get more information, we just write a plus c there. That's what it's about, constant of integration. All right, so then we want to clean up this a little bit. And so the 3's can reduce out. The 2, when you're dividing by a 2 in the denominator, that flips up top. And so just rewriting that expression. Another example we got 3/7 root of x. Once again, first thing you want to do, rewrite that in terms of the appropriate power. Root 7 is a 1/7 power. And then we just basically, antiderivative steps, add 1 to the power, and then divide by that new power. And so that's what we got. We got 8/7 because 1/7 plus 1, this 1 here is really worth 7/7. And so that's where I'm getting the 8/7 from. And then I'm dividing by the 8/7. And once again, the denominator here is the 7. We'll flip up top and make a nice 21 there. And so just doing a rewrite with our constant of integration. All right, another example, 3 over x squared. Again, do a rewrite. Rewrite that puppy as a negative power. And then follow the same steps. Add 1 to the power. -2 plus 1 will give us a nice -1. And then divide by that new power. And so just to kind of rewrite that, we would have -1 power means bring the x downstairs. And then we've got a -3 over x plus the constant of integration. So basically, just following the same steps as we kind of the opposite steps that we did for derivatives. We're doing antiderivatives. Add 1 to the power, divide by the new power. Okay, so now, this one looks complicated, looks overwhelming, but one of the first things you want to do is do a rewrite. Separate the 2/3 from the x part. This bottom here is really x to the 1/2. And when you're dividing, you subtract 1. 6 is really 12/2. So it's 12/2 power minus a 1/2 power. And that's going to give me 11/2 power. So first thing you want to do is separate your coefficients, deal your x's, kind of rewrite it in power. And then I'm ready to do the antiderivative. I add 1 to the power. Well, adding 1 is the same thing as adding 2 over 2. That's where I'm getting the 13 from. And then on the bottom there, I'm going to divide by 13/2. And once again, the 2 part is going to come up top to multiply that other 2. The 3 and the 13 will multiply together. Ooh, I got a typo here. I just realized that should be 39 down there. So right here, that 4 over 13 should be 4 over 39. And then the half power is really a square root. And then I've got x to the 13th plus that constant of integration. And once again, that should be a 39. Another problem here, once again, may look overwhelming, looks like, oh, it's so complicated, but just do a rewrite. That x squared goes to the x to the 8th, also goes to x to the x to the 6th. And so just kind of doing a rewrite. Now it's a straightforward power rule. And so we're going to add 1 to the power, so that's a 7 power, divide by that 7. Add 1 to the 4 power, make a 5 power, divide by 5. And so basically we got our problem plus the constant of an integration. Another problem, here's an exponential. So basically the exponential, where when we took the derivative, we multiplied by the 4, but since we're going to do antiderivative, we're doing the opposite thing. So instead of multiplying by 4, we're going to divide by 4. And yes, the exponential antiderivative is itself. For the polynomial part right here, this nice expression, power 5, becomes a 6, adding 1 to the power and dividing by 6. And just kind of clean that up. We get a nice little 8 where it was 32 over 4. That's 7, 6. I can't do anything with, so it's stuck with that. And then plus our constant of integration. Okay, another problem we've got here, our last problem that we're going to be looking at. This one's got a little twist, so be ready for it. I'm going to be up front here. They're going to have a little twist at the end of it. We'll deal with it. We'll figure it out, but I do want to warn you. Okay, so when are we doing this? Just like before, do a rewrite. So when you've got an x to the 6 in the bottom there in the denominator of that fraction, it's really x to the negative 6. That 4 over x squared, 4 to the x to the negative 2, and then I'm bringing up that x for an x to the negative 1 power. Okay, so now we're going to do the same power rule all the way through for the antiderivative. Going to add 1 to the power and divide. Add 1 to the power, divide. Add 1 to the power, divide. Whoa, wait a minute, that's not legal. First two parts of this problem, perfectly fine, everything's great. But the second part, notice we've got 0. If we add 1 to the power, we get 0, but then we got to divide, and it's dividing by 0, and that is so illegal in the math world. Okay, so what is going to happen? How do we deal with this? Well, we can. When we do the antiderivative, remember, we are playing with, this is the derivative. We're starting with the derivative, and we're trying to find whose function will make this derivative. So, derivative of what will make an x in the denominator? That's the catch. That's what we're playing with. And this only works where x to the 1 power in the denominator, or an x to the negative 1 power. So, whose derivative will put an x in the denominator? Well, that would be the natural log. So, rack your brains. Remember, when we were doing derivatives of natural logs, it was 1 over the inside. So, the derivative of ln x is 1 over x, and that would give us what we started with. And so that's working backwards. So when you're doing the derivative of x to the negative 1, just be careful. And remember, can't use the power rule because that would mean dividing by 0. It's the antiderivative of that would be the natural log. And then we want to clean up this expression. And so let's clean this puppy up. We've got this negative power we can bring down, put that negative in front. We got a negative 1 with a 1 here, or negative there, so that's a positive there. And bringing that x downstairs. And then we got that 3 halves ln x plus c. So if we took the derivative of this is the catch. This is this vicious circle. Derivatives and antiderivatives. If we took the derivative of this, what we would end up with is actually, is actually what we started with. So when you do the derivatives and antiderivatives, do this vicious cycle, you basically end up with what you started with. Okay, and so hopefully that made sense. Got some examples going on here for you. So give it a little try, give it some practice. Take care. See you later.